Okay, so answers to the first order. So we have 5 root x7 plus 12 all over 3x cubed. So remember, if you do want to take the bottom to the top, then it'll just be the x that goes to the top. So it'll be x to the minus 3. Now, the way I prefer doing it is I prefer writing that in the form. So it's 7 over 2. Remember, for our powers and roots, divided by 3x cubed plus 12 over 3x cubed. Then simplify each bit separately. So 5 over 3 can't be simplified. Take away the powers because we're dividing. So 7 over 2 to take away 3, it's 1 over 2 plus 12 over 3, we simplify to 4, and no x's, divided by x cubed is x to the minus 3. Yeah, if any of you put 15 in an answer, I might actually cry. Okay, next one. Y equals 4x e to the 3x minus 1. Now I just need to check that because at the minute you can't see the minus 1, and we want to find the gradient, so that means we need to differentiate it. It's a product, so we'll need u and v. Differentiate them both. And then the product rule says we times them. We do that diagonal padding. So it's 12x e to the 3x minus 1 plus 4e to the 3x minus 1. Sub in x is 2. So we get 24e to the 5 plus 4 to the 5, which can be simplified to 29e5. And that's the gradient. I don't have to do anything with it. Okay, third one, partial fractions. So 5x squared take away 8x plus 1 over 2x, x minus 1 squared. I'm going to write that as a over 2x plus b over x minus 1 squared plus c over x minus 1. And it times it by the bottom. So I'm going to get 5x squared minus 8x plus 1 is a times x minus 1 squared plus b times 2x plus c times 2x times 1 of the x minus 1s. I'm going to sub in my magic numbers. So for the 2x, x would be 0. So I get 1 equals, these will disappear. So I just get this one, minus 1 squared is 1. So here's just 1, nice and quick. My next magic number is going to be x is 1. So into here, 5, take away 8, minus 3, add 1 is minus 2. That disappears, so let's get 2b. So therefore, b is minus 1. And to get c, I'm just going to pick a random number. So I've used 0 and 1, so I'm going to use minus 1. Why not? So I get 5 plus 8, which is 13, plus 1 is 14. Minus 1 is there, gives me minus 2. Squared gives me 4, so 4a. Minus 1 into there gives me minus 2b. Minus 1 into there gives me minus 2. Minus 2 there, so minus 2 gives me 4. It's 4c. Sub in the numbers. So 14 equals 4 times 1 is 4. Minus 2 times minus 1 is plus 2. Plus 4c. So I get 8 equals 4c. So c equals 2. So I've got 1 minus 1 and 2. The next one asks us to integrate this. Well, instead of integrating that, I can integrate this. So, first one, well actually, first of all, just to help, I'm going to write this bit here as minus x minus 1 to the minus 2. Now these have got powers minus 1, so therefore they're going to turn into ln's. So this first one is going to be ln 2x, but if we differentiate that, we get a 2 in the top, so I need to divide by 2, so I get a half. With that rule, integrate that. So add 1 to the power gives me -1. But then if I differentiate that, I'll get -1 at the front, which is what I want. So I'm going to leave that as a plus at the front. I'm essentially doing -1 divided by that -1, which gives me +1. And this, ignore the 2 and get ln x minus 1, which differentiates to 1 over x minus 1. So I need to times that by 2. Plus c. Yeah. Now, this bit, if you're happy with this, we could stop this now for the next little bit. However, this term here, some of you might spot you can integrate that slightly differently. So that integrates into that, but it can also integrate into, well, if you imagine I can factorize out the half, and 1 over x gives me ln x, and then times by a half, plus c. And the reason why these two things look different, however, still gives me the same answer, is because of this constant at the end. This term here, a half ln 2x, there's a times there, so I can write that as a half ln 2 plus a half ln x. And this here is just a constant, so that can be combined with the c. But anyway, that's just there in case any of you did write that as your answer instead of the 2x there, at ortho. Obviously the constants will be different, but it doesn't really matter. And then 5, a fly bug is traveling, don't know why I put bug, a fly is traveling with constant velocity by 1. Now, constant velocity, so if you try and use Suvat, that means u and v are both this, and a would be 0, because constant velocity means no acceleration. So instead of thinking about Suvat, you want to think of this formula. The position vector equals its initial vector plus the velocity times the time. So we have, it started at 7j, so that's 0, 7, plus 5, 1 times t. So I can write that as one vector like that. We know that t is 3 seconds, so r equals 15, 10. And we want the distance from 3, 5. Well, first of all, get a displacement from 3, 5 by taking vectors away. Get 12, 5. Then the distance, or the distance of that, that's when we use Pythagoras to the magnitude. 12 squared plus 5 squared square rooted gives us 13 meters.